I see the flying car industry as game-changing when it comes to not only future warfare, but future military operations. Just as important, humanitarian relief operations, hurricane support, all the things that we do defense of the homeland. If you start thinking about these devices as nodes in a network, it fundamentally changes the game.
Agility Prime is a program with a vision of world impact. By partnering today with stakeholders across industries and agencies, we can set up the United States for this aerospace phenomenon. Potential outcomes are rewarding and transformative with both military and commercial applications.
I want to offer my congratulations to Dr. Roper and his team for achieving this revolutionary rapid contracting and prototyping method to bring industry and DoD together to develop this new exciting technology with both military and civilian applications. This technology will have great benefit to the needs that we have in Alaska and the Arctic, where conventional aircraft, vehicles, and vessels oftentimes can't operate.
Agility Prime is part of our Defense Department's long history of turning futuristic ideas into reality. I'm proud that the federal government is investing in revolutionary ideas. Agility Prime is leading the way.
This launch of Agility Prime is so exciting. This technology has the potential to make vertical flight more affordable and more widely available. And with the encouragement of the U.S. Air Force and the entire federal government, American companies employing American workers can gain a head start and win a fair share of this lucrative market. eVTOLs have the same agile, vertical takeoff and landing capability as helicopters, but are quieter and should cost much less to operate because of their electric motors.
We are becoming a trusted innovation partner in commercial tech. I could not be prouder of this initiative. I could not be prouder of this team. And I am excited to see how quickly we can go to help commercialize this market for our nation so that our warfighters have options they don't have today, and our nation has an economic advantage far into the future. Innovation is a battlefield, and Agility Prime is just one way we're going to win it.
Agility Prime seeks to ensure a global advantage in advanced logistics technology. Agility Prime can reduce the risk of adversary commercial dominance, resulting in military disadvantage. As the United States Air Force looks at generating combat power away from runways, those distributed logistics aircraft must be runway independent. This new transformative capability is a promising opportunity to conduct that mission in an affordable and a scalable manner.
Today we gather for Agility Prime to drive transportation innovation, lower barriers to entry, and expand our partnerships.
We see a time when automation technologies make the requirements on the pilot much less. And we see flying as being accessible to a much wider range of people.
And it's really a great credit to Agility Prime. They could put on this virtual event with so many hometowns of the United States represented. You know, industrial base is not really about just what a country can make. More than that, it's about the people who dream up what to make. And then, of course, those people who make it.
Good afternoon, everyone, and welcome to the latest installment of the Agility Prime Events series, this one entitled Expanding the Market and Use Cases. I'm Ian Clues, contractor, technically out of the Air Force Warfighting Innovation Capability, AFWERX, which is an organization in the Air Force that helps frame and solve the institutional problems of the future. But I've been detailed over to Agility Prime to help out with stakeholder management and a few other duties. This effort is sort of a culmination of our desire to engage in government stakeholders, both inside and outside of the DoD, to build a community of interest around orbs through the Agility Prime project. In this webinar, we have a set of some of the stakeholders who are interested in using orbs. They constitute a small sample, but representative sample, of the organizations interested in this transformative technology. But before we get to them, I'm going to turn over the mic to Colonel Nathan Diller, who has led this effort, who will be followed by Lieutenant Colonel Charles Brisbois, who's the Innovative Solutions Division lead within AFWERX. Colonel Diller, over to you.
Super, thanks Ian, and thanks to the whole team here. As you all probably know, it is a big team effort across the Agility Prime team. We have, as Ian mentioned, a good number of government support contractors who we're able to bring in. Ian has been a great teammate. Ian also is a reservist in the Army. He has been supporting COVID efforts, deployed for some time. He's back now with us full time, and we're happy to have him. We also have obviously folks in military, as well as our government civilians that make up this Agility Prime team as we look forward to the various different opportunities that are out there. Today we have a super lineup, and just a little bit of a reminder again of our general approach here on Agility Prime, right? This idea that there's a fantastic market. If we look into the future, Morgan Stanley, I believe, is predicted by 2040, the potential of a $1.5 trillion a year market that's being suggested out there. Our intent with Agility Prime is certainly to move forward in that market and try to support that market. But our hypothesis is that these underlying technologies have potential value in the very near term in a variety of different use cases. And so are there ways that we can begin to build other markets and potentially those more near-term markets in the very near term? So as we do that, we're going to talk this week about some of the operational use cases. I'm going to give just a little bit of a preview also for next week. So we're going to talk on these operational use cases. One of the challenges that we certainly have from a cost perspective, having grown up and having had the taxpayers spend several $1 million on my flight training as an F-16 pilot and eventually a test pilot, the idea that eventually we would like to at least make a lower threshold for the pilots that we're flying, and eventually get to a point potentially where these vehicles are actually flying themselves through autonomy. So next week, I encourage you to join in next week for a discussion that we'll be having on autonomy. I also have a special guest next week. Dr. Roper will be joining us for a couple of special announcements at the end of next week's session. So definitely mark your calendars for next week. As we get into the discussion this week, though, this idea that there is a near-term market, that there are use cases out there that we think could be immediately helpful in terms of reducing cost, things like range support, things like disaster response, our support to civil authorities in cases like hurricanes, for example, where you don't necessarily have the roadways or the runways. And so we have some really great speakers here that are going to talk to that to see how we look, again, in the very near term as we start into testing that is going to happen. We had announced a couple of companies just over the last few weeks who are progressing well. You might have seen, if you haven't, there's a fantastic article by Wired showing the new vehicle being put out by Beta Technologies, who is a partner here with Agility Prime. So there is substantive forward progress being made towards the vision of near-term use that you're going to hear today. As we look to that near-term use, one of the key teammates that we have in this effort is AFWERX, and this is the Air Force's organization that looks to future concepts. This idea that we certainly need new technologies, but as important as those technologies are the innovators that think about how to use those technologies. And there are few that are doing more in this effort, in that innovation, than BB joining us here from AFWERX, picking up in his efforts and roles in the disruptive technologies sector that he's been looking at. Certainly potential for this to be part of those future disruptive technology. And we'll hand it over to BB as we launch into today's fantastic panel on the additional market and additional use cases for orbs into the future. BB, thanks for joining us this afternoon.
Hey, thank you, Nate. I appreciate the opportunity, and thank you to Ian and the rest of the team behind the scenes that have set these up. You guys have done an incredible job showing the Air Force how to do this and really setting the standard. I don't have one of those nice backgrounds that the rest of you guys have. This is my first time actually speaking on one of these. I've watched the rest of them, so after this, maybe you guys can give me a background or help me figure that one out. Yeah, so to talk a little bit about our organization, AFWERX, the Air Force Warfighter Integration. Essentially, the Air Force looked at our Chief of Staff when he took the seat, looked at the Air Force, and he said, we've got to change faster. And he started lots of lines of efforts to do that. One was directly working with the acquisitions community and Dr. Roper and what we call Secretary of the Air Force for Acquisitions, SAF-AQ. And that's where Nate Diller sits on that side. And that's where now AFWERX is planting its flag. On the other side, he looked at it and said, you know, on the strategy side, we've got to have an organization that can build concepts for how we compete in the future, right? And then match those concepts to capability development, to actually going back to the acquisition community and saying, you know, these are our concepts. This is how we're going to apply these technologies. And we want you guys to go out and acquire them. And so both are running in parallel, and we're starting to merge some really innovative stuff that's happening on both sides from two different organizations, AFWERX on one side and AFWERX on mine. And my job in particular inside of our organization is that I look at disruptive technology, as Nate said, and I have a team of about 15 guys that are assigned to each technology sector. And so we cover quantum, 5G, disruptive energy concepts, microelectronics, autonomy, Internet of Things, directed energy, blockchain, bio. If you can, you know, think of a disruptive technology, and by disruptive, I mean it changes the way society interacts. You know, that technology is going in a large part to change society. I think it fits the definition of disruptive. Then we're looking at it and we're trying to figure out how we bring that into the Air Force faster. And with Agility Prime, you know, when this was brought up, not only is it a $1.5 trillion, you know, economic benefit to the United States if that lands here, but all of the other parts, when you start looking at autonomy, right? All of the things we're going to learn in Agility Prime through autonomy are going to be applied to all of our other aviation systems and our driving systems. And the United States wants to be the leader in that. Same with energy. We're having discussions right now with the Department of Transportation and others throughout the government and commercial on how do we bring the infrastructure that's going to be required to drive all of these electrified vehicles, whether they're ground or flying vehicles in the future, right? And how do we get there faster? And how does the Air Force help in that? And how do we take advantage of it early and gain the competitive advantage from it? You look at 5G. How are we going to communicate with these? Internet of Things. You know, again, 5G enables the Internet of Things. And then human performance, the mixture of man and machine that's going to be enabled by having these AR, VR capabilities and rapid communications that 5G enables right there for the people that are operating these vehicles to work with them at a very low latency. You know, so all of these technologies come together inside of Agility Prime. And it's really, this is the only program that I've seen across our entire portfolio that pulls on so many of these strings. And it's really exciting. So I'll wrap up my comments there, but Nate, I just want to thank you for pulling us into this and just say thank you to the organization. You guys have done an amazing job of forwarding this for the Air Force.
BB, super. We really appreciate the partnership there with the AFWERX. Again, unless there is legitimate viable end users for this, you know, we're just doing experiments for now. And that's the reason we think the ability to field by 2023 is critical, and you guys all play a critical role in that. We have a super panel. I'll let Ian go ahead and introduce the broad mix of folks that we have across this user community, looking at these fantastic different use cases. We have essentially almost all the services represented here, including a fantastic background by our Coast Guard counterparts as well. So Ian, back over to you. Looking forward to the discussion here.
Thanks, sir. And thank you as well, Colonel Beebe, for the opening remarks. So going across the panelists, starting with in the DoD, we have Lieutenant Colonel Rory Feely of the Naval Test Pilot School, Marine by background. We also have a few other Marine representatives, Mr. Thomas Heffern and Master Gunnery Sergeant Chris Anson. We also have Air Force APSOC representative, Captain Mitch Kim. As Colonel Diller mentioned, we have representative from the Coast Guard, Lieutenant Commander Bill Haywood. And to pull in some interagency flavor, we have Nancy Mendonça from NASA. Thank you all for attending. I guess I wanted to kick things off by putting out our first question, which is, what does your specific sub-organization do, and how do you think you might use these transformative aircraft we're calling orbs? I'll push that off first to Colonel Feely, if you'd take the time to introduce yourself a little bit further and answer the question.
Thank you again. Thanks, Colonel Diller, and everybody else who's involved in this for including not just me, but also Navy, Naval Test Pilot School, and definitely appreciate the approach to, or the approach, the big team approach to this effort. I only caught part of your question. It kind of cut out, but I'm assuming it was, hey, how do we foresee the use of orbs for future technology uses? And during the introduction, you know, I heard very reputable institutions such as NASA on board, and they're, you know, I just had a phone call earlier in the week with a former colleague of mine who's now an astronaut, and one of her predecessors who was an astronaut who was a former Army aviator, and they are looking at developing, using multi-rotor systems to develop rapid acquisitions for training simulators for lunar landers. So that's a kind of an imaginative stretch right now. I wouldn't have predicted that, but that just kind of gives you an idea of a spectrum of where these technologies can be used. You've seen in the media, the various potential uses, you know, the Amazons of the world wanting to deliver packages by drone. That seems to be a good way and connotes many visions of future sci-fi movies. In the Navy, we look at the UAS world, and we look at the size and scale of those UASs, and somewhere along the way right now on our current spectrum, there's a demarcation line that changes how we power those. If we power them with electric motors and or electric subsystems like batteries, or somewhere in between, they may be powered with electric motors and some sort of power generation system. And then at the higher scales, the technologies are still using kind of conventional fossil fuels. But that's a simple approach to looking at them. There's a bunch of underlying technologies. And when I think about that, I still always come back to the one analogy in my head that helps explain it to the common person, and that's the cell phone. The cell phone was an integration effort that, you know, exceeded our wildest dreams. We had digital cameras, we had computers, we had touch screens, we had all of those things. And, you know, a company comes along and says, hey, what happens if I package that up really, really well and stick it into a device? What's the synergy there? I foresee those same things happening with modern technologies, and aviation seems to be the space that we're leading towards. So we've really got high quality electric motors. We've got significant amounts of computing power. We're looking at AI platforms and self-generating software and other things. We know our location on the planet really well. We're integrated across devices. Is there a way we can package that up and
make it do something useful for us in the flying space? I think the answer is yes. And the good thing about that is the aperture is only getting bigger. The solutions are going to be used in many, many different places as the years go by. You know, you can see it everything from right now, how if you go to buy a house online, there's always an overhead drone shot. That's kind of a very simple one. But, you know, whether it is a troop following eye in the sky kind of concept, where you would not only require flying aircraft, but also really smart hardware and software systems on board to follow a warfighter in combat and amplify his capabilities. So my point is, there's a wide spectrum, and in order to get after the corners of that spectrum, you need imagination. And the best imagination is going to come through collaborative environments with teams and people who have ideas. There are no, like, if you're sitting there and you're thinking, oh, we'll just do this and that's the obvious answer, I would say that go research the history of technologies. They're almost never used how they were first intended. And they definitely come in and they disrupt the ecosystem. So I don't know if that addresses your question. I didn't really kind of say it'll be used for this. I said it can be used for a range of things, and that range of things is whatever we want people to do. I will say history has always wanted people on the move. That's what we do as a species, whether it's exploring the continents or extraterrestrial stuff. And if you take a look at how quickly transportation technologies have been adopted, they get adopted much faster than we think. And in general, the old technologies do not become extinct. They just get used in different ways. Horses are still out there. Trains are still out there. Cars are still out there. Planes are still out there. The bike is still out there. And people still walk. So whatever the next technology is, it's going to add to this ecosystem of current technologies if it's used particularly in the transportation space. It's not going to make anything extinct, but it will make us more capable. Thank you.
Thank you, Colonel Feely. I wanted to pass it over to the other Marine participants we have, Mr. Heffern, Master Gunnery Sergeant Anson. Do you have sort of things to add from within your space in the Marine Corps about how you think you might use orbs?
Sure. This is Chris Anson. I'm joined by Tom Heffern, so I'll lead off, and then I'm sure he'll correct anything that needs clarification. Currently, I work for Marine Corps Warfighting Lab. Been in uniform 25 years, specifically in the area of logistics. So lots of operational experience with distributed operations, served in an acquisition role along the way. And the past 3 years, we've really been working with the small logistics-focused UAS. Early experimentation, getting them out there where ground forces command, control, and operate these systems, and how effective that is with tactical distribution. So really excited to be part of this from the Marine Corps. We are evolving and kind of changing the way we do business. We're looking at distributed operations at a mass scale. We're looking at small advanced bases out there. So lots of important things as it ties into Agility Prime. Things like maintainability, airfield independence, simple systems both to maintain and operate. We're not going to have this infrastructure out there to, have all these technicians. So as we do run into issues, we need to be able to troubleshoot and fix these things quickly. As far as operators, automation and autonomy eventually are important attributes of these systems as we use them throughout the forward expeditionary areas that we're operating in. Lots of use cases for the Marine Corps, areas that we're looking at utilizing these systems, tactical transportation and resupply missions. So moving Marines around, tactically, administratively, supplies, getting them out to remote locations. Really, it's a do-all. It's a pickup truck that we're looking at utilizing, keeping it simple as mentioned, and reaching places that are really unattainable by our current systems, ground vehicles, things of that nature. So really important. Also general engineering support missions, you know, getting robots as we're building up these future locations. We're going to be on the move a good bit. So we're not going to be in fixed positions. So we need to be able to adapt and move supplies and fortify positions to a certain level. Also was mentioned humanitarian assistance and disaster relief. It's a huge part of what the Marines do. It's not our primary mission, but we are forward deployed. So as those situations, you know, emerge around the world, we're ready to react. And these systems are great to serve in that capacity. Logistics, maintenance support missions. There is technology throughout the areas that we'll be operating in. We need to get the technicians out to some of those places to repair, troubleshoot, and fix systems. So another great role for these for the Marine Corps. One that's on everyone's mind is CASEVAC. You know, we do have injuries, and these platforms could be used in that capacity to get those folks out of harm's way to the nearest medical facility and treatment, and to, you know, provide the life-saving treatment. And then services, just normal stuff, administrative services, whether it's postal, you know, getting mail out to folks in remote locations. It's important morale. It goes a long way in the Marine Corps when you're in less than ideal conditions. And then just supply all around, logistics. And we're talking about tactical distribution. So getting things out, you know, flattening the supply chain as much as possible, and not having these big supply, we call them iron mountains. We're getting away from that in the Marine Corps. We can't sustain that. It doesn't make sense. So we want to take the exact part and get it out to that customer, minimizing those touch points along the way. So lots of use cases for the Marine Corps. Really excited to be a part of this. And I'm going to pass it over to Tom Heffern to tidy up anything I missed and add to. Over.
No, I mean, I think you hit it really well, Chris. You know, the big theme, if my coworker here doesn't act up here in a second, she's starting to get antsy on the floor. My little Shih Tzu. One of the key themes here, I think, is freedom of movement, right? So, you know, I'm sure there's a lot of fans of mass transportation and public transportation out there, but you know, in many cases, the challenge with, you know, riding the metro or riding the bus is that you're constrained to meeting a schedule, someone else's schedule. What a lot of these orbs are going to enable us to do is to provide that freedom of movement and action out to a wider audience of Marines, to enable all those functions you just talked about that we traditionally would have had to outsource to our aviation brothers. I was going to say some of my experience as a rotary wing pilot, the most gratifying times I had is when I was heavily coupled in with the operations that were going on and was like face-to-face supporting Marines, utilizing my machine in a way to do exactly what they wanted done. Not necessarily just providing like a transportation service, but in some cases just lifting up pallets and maybe only moving them a couple hundred yards, but it was a couple hundred yards that saved them countless man hours of time moving things. So these are going to be freedom of action, air transportation tools that we can use in any number of ways. So it's an exciting time. I think that once these technologies start to come around, we're going to be, the Marine Corps that's kind of Chris and I's job, is to encourage the rest of the Marine Corps to do that, should be in a position to grab a hold and immediately begin to utilize them in a variety of functions. It's not that we're necessarily, the message we have to take to the rest of the service is that we're not necessarily going to these aren't going to immediately be these big long-range tactical transportation, amphibious assault. Here comes the wave of orbs, and those are the things we think about in terms of aviation, right? We're thinking about V-22s and 53 Echoes crossing the beach and doing amazing things. But these orbs are practical devices that we could actually begin to utilize now in many of our training environments where there's all kinds of tactical, semi-tactical, and admin moves that need to be taking place for 1, 2, 3 people, a couple of cases of cargo, variety of spare parts, things that traditionally people haven't thought about utilizing air for because it's such a pain. But when we give them this toolkit in their hands, they'll be able to operate in a way they haven't been able to operate before. So good. That's all I got. Exciting
Great, thanks,
times.
Joe. Indeed, very exciting times. Thanks, gentlemen. I now wanted to push the question over to Lieutenant Commander Haywood from the Coast Guard to give sort of a inside-outside DoD perspective on these technologies and where the Coast Guard might be interested in using orbs.
Sure, thanks a lot. The Coast Guard, we do everything very similar to the DoD in a lot of ways, and just always smaller and cheaper if we can get it. And I've spent the last 12, 15 years as a helicopter pilot. I'm currently at staff, and where I work now is Unmanned Systems. So going from being a pilot in the cockpit to now trying to put all pilots out of the cockpit. And that this was particularly interesting to all of us in our office, which is a small office, the idea that you could have these be unmanned or manned. And so we like that idea because there are some missions that it's, at least right now, given the current technology, it's really hard to imagine an electric VTOL vehicle that has the capacity to do a medevac, say, or hoist a bunch of heavy people off a sailboat offshore and be able to stay on scene. So, I mean, I can sum up a lot of the stuff that the other gentleman said is the same thing we're interested in. Basically, any mission we can do with an aircraft right now, we could do with one of these, except for maybe long-range surveillance type of stuff. But the down and dirty, down to search and rescue, medevac, rotary wing air intercept, even airborne use of force meetings that we're doing, missions that we're doing downrange, those could all be done with these kinds of things. And it's especially appealing to us, the idea that once they're up and going, the fact that this orb concept with the way fewer pieces and the modular setup to reduce that kind of maintenance and cost and have these things on scene wherever you need them to. Basically, we think of the same way. It's a truck. We don't really care what it is. We just want either the people on scene or the sensors on scene or the parts run or whatever it be. So yeah, that's kind of where we stand. We're really happy to be a part of it. Definitely happy to help with more specific use cases as we move along, and we're excited to see where the technology can go. Yeah.
Great, thanks, Commander Haywood. I'd like to now get Nancy Mendonça up to see what NASA has to how they're interested in using these vehicles. You're still on mute, Nancy. One more time.
Nancy, you might need to call in on a cell phone. I don't think, oh, there you go.
There we are, yeah.
Is that okay? Yeah, I've got my cell phone on, my computer on, and I've got 2 monitors, so I'm looking back and forth. So I would like to thank Nate and Ian for the opportunity to participate in this. And I'd kind of like to build on what Rory mentioned. Our science folks are definitely using the helicopter designs and knowledge to do science missions. So we have it from that aspect. From within the Aeronautics Research Mission Directorate, we aren't interested in buying them, but we are definitely interested in working with the companies who are developing the configurations for a couple of reasons. One, we're partnered with the FAA to work on certification for commercial uses. And the more configurations that are out there, the more we can learn, and the more we can identify the best practices and lessons learned that we can spread around the community, so that we can have common advances, and everybody's not going down the same blind alley. And we would also, part of that is we would also like to make the configuration or the certification process for commercial uses a much more smoother and easier process, and supporting our FAA partners in doing that, because we think that the vehicles are going to rapidly mature, and we don't want to have long lead times to add a new safety feature to a vehicle. So that's a very process. So the more configurations are out there, the more knowledge we get, the better we can work on that process. Also, the more configurations that are out there for the commercial uses, our tools that we use and distribute around the community for design aspects become better because we can validate our tools with the different configurations. And then partnered with that, we're also working on airspace design and understand that, their airspace design and the vehicle configurations are very integrally linked because, a vehicle that has a certain configuration for energy purposes would like to have a certain approach path and a departure path. So we need to understand, the vehicles that are coming in so that the airspace procedures can handle the vehicles and that the vehicles can fly like they want to in the airspace. So if 70 knots is the most energy efficient speed, we want to make sure that the procedures, allow the vehicles to do that. Or if it's, it's 120 knots, whichever, we can understand the vehicle configurations there. So we're really excited with the Agility Prime because we think that the program is going to get these configurations out there, that we can see them, that we can start working with the different companies on them. So, and Nate, I wanted to tell you that you now, I've heard you now have 3 rotor heads online, and I think we're going to outnumber you.
That's actually great news for everyone.
It is. Thank you, Nancy. And then I want to round things up with Captain Mitchell Kim from APSOC. If you could come online and tell us what you guys do and how you think you might use orbs.
Hey, thanks, Ian. Can you hear me? Awesome. Just wanted quick thanks to the Agility Prime team for having me here. Excited to talk about from the APSOC perspective. Largely, we remain engaged in the CVEO fight while also doing pathfinding for the Joint Force to prepare combat for adversaries, both peer and near peer. What is so exciting about orbs? Light mobility. A lot of requests that come in from AFSOC don't require the full cargo load of a C-130. So if we think about these smaller loads that are critical or enhancing to the mission in resource-constrained environments, that's a huge, huge benefit to AFSOC. So kind of echoing what the Marines said, the humanitarian disaster relief, CASEVAC, all those missions we're on board with. That's how we kind of see this being used. Special tactics resupply, as well as agile logistics, expeditionary operations. That's about it from our perspective. A lot of great conversation has already happened. So thanks, Ian.
Sure thing, Mitch. I wanted to pull in Colonel Bruce Boys again and launch a new question at you and sort of ask what is attractive about transitioning to orbs and how they might be positioned well within the overall aircraft portfolio.
So if I understand your question, you're asking why are orbs beneficial to us in the future force design? Is that kind of what you're asking?
Exactly.
Yeah, I think all of the participants have talked about it, and I think I heard one guy say anything you can do with a helicopter right now, we think we can do with these. And obviously in our future force design, we are looking at areas in which we don't want to send manned pilots, right, or manned aircraft, and so I think the autonomy function of this and what autonomy provides you. The ability to go into places that are dangerous and dirty and survive and bring either men or material out of those environments is going to be a huge player in our future force design.
Great, thanks, BB. I also wanted to mention from a facilitation point of view that if everyone listening in, all the attendees could put your questions into the Q&A section of the Zoom rather than in chat, we'll be able to look through them and hit them up at the end. But back into it, I wanted to, Colonel Feely, it looks like you put your thinking cap on when I sent that question to Colonel Brisbois, and I'm not sure, wanted to ask if you had any thoughts about the attractiveness of transitioning to orbs and how they might be a great fit for the aircraft portfolio.
Very rarely am I at a loss for words. I personally like it from an attractiveness standpoint, because in my current role, I am responsible for educating, and it's an advanced education role, a lot of our aviators about how we make aircraft fly and how we evaluate them in their effectiveness for doing missions. So some parts of that will always change and some parts of that will never change. So the physics side of it never changes. The parts that always change are our understanding and our capability on materials and other advanced technologies and concepts. So in my opening comments, this is down to our imaginations and the problems we have to solve. I mean, that's what people do when they go after challenges. And, you know, from a Marine Corps perspective, like you heard from McWill, distributed battle space, how do I supply that? All of those are all legitimate uses for these vehicles, as well as what we currently have. I mean, we're currently doing those missions as well, but to a certain extent, this is, are there better mousetraps out there and what's the upside to those better mousetraps? What I will say, I think, is a fundamental shift that may be happening additionally on the logistics side as well, as we go from a mountain of iron, as it was also said, and I like the way that sounds, to more of a distributed, you get out of, and this is maybe a little bit of a downside too, you get out of the efficiency side and you get into the resiliency side. So what does that mean? In an efficient situation, generally somewhere along the way in a system, you're going to have a single point of failure. And if you think of a computer network, like the internet or even something smaller, there are multiple paths of connectivity. So even if one goes down, you know, that's a very, very slight degradation in the system. Orbs offer us that opportunity because we're going to take big, potentially more efficient, or this is a single use, big, potentially more efficient ways of distributing product or stuff or capability and maybe put it in a more resilient format. The big, more efficient, that sounds good, but that also comes with challenges in terms of time, underlying infrastructure, stuff like that. So a lot of that may melt away as we transition. So yeah, I mean, you know, whatever it is that people want to do, whether it's I move electrons around my ecosystem, whether I move product around my ecosystem, whether I just follow people or move people around my ecosystem, I think these vehicles are going to have that capability. And you know, the big change, and one of the drivers right now in the UAM space is, hey, it's more environmentally friendly, and not only on sound but also on you know, exhaust-like pollutions. And then it's going to solve potentially problems in our city infrastructure where the current systems like connected roads and the plethora of cars and all of that infrastructure is at gridlock and standstill. So I hope that answers your question. Over.
It does. Thanks, Colonel Feely. Now I wanted to take on I wanted to go back to Captain Kim to see if he had sort of additional thoughts on the pulling in orbs into the portfolio, considering the range of aircraft that AFSOC currently has access to.
Hey, thanks, Ian. Can you repeat the question real quick?
Essentially, considering the range of aircraft that AFSOC has access to, I know there's a number of sort of specialized aircraft along a range of sort of profiles. What is attractive about the potential for these specific types of flying vehicles in your portfolio?
Great question. So the great thing about bringing orbs into this, basically provides relief on the system. So mentioned before in the previous answer that a lot of requests that come in don't require the full cargo space, personal allotment that the plane can actually hold. So if we're able to do this with less fuel, less resources, less people, then it provides us the opportunity to divert our resources, time, energy, money, people towards things that we can do a little bit more efficiently.
Great, thanks, Mitch. I now wanted to turn over to Captain Terrence McKenna. I believe you had done some work on range operations. And if you could speak a little bit to that and the use for orbs for those.
Sure, absolutely. And I'll just talk briefly about it today. We have a great webinar next week on autonomy, and so that's where we'll go into a lot of the use cases for autonomy focus. But I wanted to make a quick plug here for some test and evaluation ecosystem use cases. So we're obviously using the test and evaluation ecosystem to test and evaluate the Agility Prime orbs, but we'd also like to use that ecosystem as surrogate platforms for autonomy core, for software infrastructure, to use them as surrogate vehicles for objective systems to evaluate the potential savings and to accelerate the development timeline by having orbs as surrogate platforms. So there's a lot of benefits there. If you think about existing surrogate platforms that we have within AFMC and other test organizations, you think about things like Vista, you think about things like the Learjets, and then you have a lot of stuff kind of on the small UAS platform, but you don't really have anything in this new trade space, which is very exciting. And so being able to use autonomy orbs as autonomy surrogates, either as dedicated autonomy surrogates or as the operational platforms themselves being surrogates as they move into the operational framework as well, is a very exciting proposition. And by having lower cost, the ability to test some of these things, by having the rapid turnaround, and by actually having the potential option to not just do autonomous tests, but also optionally piloted aircraft with these vehicles too, you get direct feedback from the test platform for increasing the efficiencies, increasing the feedback mechanisms there. So really exciting time, both for testing the vehicles and then incorporating it into our tests moving forward.
Great, thanks, Terrence. I want to move on to a different question and sort of ask the panel about where we may not use these vehicles, where they sort of don't quite make sense as a use case, and to some extent where investment might be critical in the near term in order to fulfill the use cases that we might imagine them in. And Nancy Mendonça, would you mind taking a first hack at this?
Sure. I can't, I won't, let's see, won't answer on the where can't we use them, because I do think that innovation will surprise us continually and that we will see a lot more cases than we could have ever imagined. Technology and barriers, I think several aspects that we're looking at systems-wise. I think the CNSI, the combat surveillance issue, is going to be really challenging. Partly because of the multiple things we want to do it, but because of the interface of data transmissions, bandwidth, both bandwidth and frequency. But the security for those, positioning is going to be a challenge. Designing a network that's not quite high altitude and is not quite low altitude cell phone range. We want something that's cell phone towers don't point up, so they're not an easy go-to solution for that. So we're also challenged on designing those architectures because we can't put everything on the aircraft, because that makes the aircraft really expensive, and then you're not going to build the volumes that we want to see for commercial applications. So we're going to have to find that that Goldilocks sweet spot on the architecture of putting on the aircraft what needs to be on there, putting on the ground what needs to be on there. And being able to exchange the data and the networks across all of those. Weather is going to be another similar challenge that we're going to see. Weather sensors. We're great at long-range weather, high-altitude weather, but we're not real great at urban weather. So I think that's going to be another challenge that we've got out there. Vertiports are going to be another challenge, and I think it's a great place that we can interface with the DoD partners on. You know, the DoD's got a huge amount of experience with, you know, landing pads and confined area landings, shipboard landings, and all of those things, and we need to pull that information in so that as we design these vertiports, that we can take advantage of that knowledge and improve on it. We had some meetings down in LA, and for about 15 years, LA required that all high-rises have vertipads on the top of them for evacuation purposes. So you can look down and you can count all of these vertipads, and I'm looking down at them going, there's no way I would ever land on that thing because there's no references around it. So as you mentioned, autonomy, or we're calling it automation, is a huge area that we're going to have to work on because we're going to need that assistance to help us make those landings where you don't have any visual references for the pilot to make, and to improve the safety, especially at the volumes. We're really going to have to step up and solve some of these issues that make these things safer so that we can have the commercial applications that we're looking for.
Gotcha. Thanks, Nancy. I appreciate it. Lieutenant Commander Haywood, would you mind coming up and taking a whack at this?
Sure. I'm still talking about places where we would see it not being useful. And like I said, given the current state of the technology, it's hard to imagine. Mostly I think of search and rescue, going offshore, being able to hover, hoist a couple of 200, 300-pound people off a boat sometimes without knowing more about it. That doesn't seem like something we'd be able to use yet. So I guess for me, it depends on the end state, the end goal, the state where we want to be with these things, and what's available now. I mean, and that's what we run into right now with unmanned systems every day. Is we're close, but the technology isn't quite there for it to be as useful as we want, or it's not as cheap as we thought it would be originally, or it actually requires more people. And in the case of the MQ-9, which we have a joint operation going with CBP, we always joke, it's only unmanned in the air. On the ground, there's a whole way more people than you would need in general, and it's super expensive. It's never anything we'll be able to buy unless something crazy happens with Coast Guard budget. So really, for what we do, if we get these things to where they have the power and the torque available to do the kind of jobs that we do, my answer is pretty much the same. We could use them to do most missions, both manned and manned, that we currently do today. It's kind of a general answer, but that's the way I see it right now.
Oh, that's fair. Thank you. And then passing it up to our Marine Corps brethren, can we start in Anson, Mr. Heflin?
Sure. I'll take a crack at this. The biggest one I see is range, where we will and won't use these, right? Range is important. So the longer legs we can have associated with these platforms, the better. That's going to be really important with the vast distance that we need to cover. So that may be a limiting factor. Also, already mentioned command and control, very important. All the data that we need to transmit is super important. Ship-based. I know for the Marine Corps and probably the Coast Guard, we're looking at maritime environments. So both EMI, electromagnetic interference, and then also environmental conditions are going to be something that we'll have to look at and address down the road as we look at putting these platforms in all types of scenarios. And then a couple of the others that I mentioned kind of in opening comments is autonomy, and I know others touched on it, but keeping that operator training to a minimum. And we use autonomy in loosely, but really either high automation in the beginning and hopefully getting to where truly autonomous systems to reduce that operator training. And then maintainability, that, like I said, simple systems. I know it's a tall order, right? Cost, maintainability, and keeping things simple is a tall order. But maintainability is important because we're not going to have these, operating out of a large airfield with all sorts of technicians. And I'll pass it over to Tom. Anything I missed?
No, I mean, I think you pretty much hit on all of it. It really comes down to performance. And as Mr. Haywood said, we would use these systems. There's nothing about these systems that would prevent us from utilizing them across a range of missions is just simply their performance. And we got to find, yeah, we can make things that have more performance, but then that will create some other downside to it. So yeah, we can make it go further and faster, but then it's bigger and louder. So what we're going to need to do is find that sweet spot of attributes that are different than the other things we already have in the portfolio that give us a new capability that we haven't envisioned. So that's what we're looking to do, is just grab a hold of these things kind of as they are, and as they turn into something that's usable, finding the right use for it that maybe wasn't previously envisioned. So we'll use them all over the place.
Yeah, great. Thanks, guys. Captain Kim, do you have any thoughts on the places where you probably wouldn't use these types of vehicles, and any sort of thoughts on where investment might be particularly valuable?
So kind of echoing what's kind of been said before, coming down to performance. Obviously, if we're in a situation where you need to be pulling some G's or doing whatever in the air in a contested environment, and the performance isn't there, and we have either valuable materials or people on board, that's not necessarily a situation at first that kind of piques our interest. We need to let the technology develop. I think a big thing with this is going to be the government and all of our partners, everybody that we have on this call here, being able to influence what the private industry is doing without kind of taking over with what they have planned for this space in general. And I know that's something that your team has been proponents of, and I think that's in the long run going to help make orbs modular to the extent where we can go off the broad skeleton of what an orb looks like and be able to plug and play different options for different use cases. And then for autonomy, kind of going back to the performance thing, it just how's the reliability, hasn't been developed sufficiently, public opinion, all that stuff kind of plays into it. But I think by and large, if performance and autonomy, that reliability aspect is hit on, I don't think there's a limit to what this stuff could be potentially used for. Thanks, Ian.
Great, thank you, Mitch. And then Colonel Feely, do you want to hop in on this?
Yeah, actually, I appreciate what everybody's been saying there. It's definitely provoking some thought. Nancy said, you know, trying to offboard systems from the aircraft, and that gets back to my comments about you can't change physics, and physics of flying is brutally honest, right? So it's hard to make aircraft fly and fly efficiently, and there's a reason why, you know, large jetliners all have roughly the same shape and aerodynamics to them. Additionally, other things along what I'll call the spectrum of risk, and I believe Lieutenant Commander Haywood talked about this in terms of SAR operations. As you examine risk of emission or whatever that is, you know, the pedigree of any flying aircraft will have to change when you start bringing people into the loop. And then you may be willing to onboard more risk in terms of the pedigree of that aircraft or the success of the mission if you get to a situation where you're willing to accept failures. And generally, as a people, we don't like to accept failures or product failures when it comes to our servicemen and women or areas of the government or areas of the public. Very enticing. And then the one thing that was kind of sticking in my head as we go through all of this, and it's a natural tendency, is we're looking at these as aircraft. It's like, is there any other way of looking at them? Yes, they're flying, and yes, they are aircraft, but we could be looking at the onboard systems like the AI piece of it or other technologies in there and going, okay, that is now replacing what a person had done previously. And if you think about the person interfacing with an airframe, and this is where people are really good, they generally make decisions kind of along two lines of effort. You know, a little bit of the training and a little bit of the experience, but they're good at making decisions in high pressure situations where all of the information is not available. I think that's a current limitation of AI. You know, how does it make a decision, you know, experientially based, training based, and with limited information. So some of those things are going to be interesting to see how they get worked out, or interesting to see how they get worked out in the future. It's fascinating stuff. Like it's just another tool at the same time. And if your only tool is a hammer, then everything looks like a nail. And what we're trying to do from a warfighting perspective is have more tools in our tool bag. Where the aircraft are not going to be used is if we already have a tool that's sufficiently good, right? When we did the Agility Prime kickoff thing, I said, hey, you can transport, product in two ways. You could have an elephant and it'll charge in there, bring a high volume, or you can have an army of ants. And both will, at the end of the day, transfer the same volume of product or same transportation requirement, but they just do it differently. And one has failures in one area and one has failures in another area. Knowing more about how this can be used from a failure perspective will tell you all that, hey, let's not do it here. But maybe looking at the other aspects of, hey, where can I take some risk and it doesn't matter, that provides us the resiliency in some of our capabilities to, move supplies around a battlefield. If I needed hasty networks, can I put up some sort of field array of communication devices for a limited period of time? I mean, you name it. It's in the imagination. And sometimes when you've been involved in the stuff for too long, you get your blinders on. So I look forward to the outside perspectives. And finishing up, one of your comments regarding industries, it's going to have to be profitable for them. So I would suggest three competing areas. From an industry perspective, it's got to be profitable. From a government perspective, we're going to have the regulation on there. And then from the public perspective, which is really going to drive the development, it's going to have to be acceptable. And I think balancing those three things will bring the right players into it. And because I truly believe it's going to be industry that brings this from a scalable perspective to make it profitable, that'll get the technology developed. I don't see the government nor the military doing that at the moment.
Great, thanks, Joel Feely. And Colonel Beebe, do you want to take our final hit at this question? I think he might have dropped. He did have another meeting that he was scheduled to hit. But that's, oh.
I'm here, Ian. Sorry, I was on technical small buttons on my iPad and I hit the wrong one.
No problem.
That's why we need autonomy. Yeah, so, I like where Colonel Fingley was going with this and the idea that we have to think about it differently and how, the ability to look at these orbs and discover new ways that we're going to put them into use, ways that we've never imagined, is really promising. And then, like I started off with in the beginning, all of the other technologies that are going to be advanced in the cause of Agility Prime are really going to be where I think we gain the most from this. And so it's kind of my closing thoughts there.
Thank you. At this point, we're going to open up the Q&A section, and Sterling has been monitoring that side of the chat, so he'll come up with some of the questions that have been posted here.
Sure. I think our first one here we can start off with for the forum as a whole is, how important will a dominant configuration be? Can you guys just speak a little bit on the benefits of having one multi-role versus many specialist platforms?
Interesting. Does anyone want to?
Sure, I'll take a quick stab at that. I think that's going to depend on the amount of specialization you want and what kind of performance you want, right? I can't send my Toyota Corolla to the dragster course and expect it to perform in the quarter mile. At the same time, I'm not going to pick up groceries with my dragster. So if you're getting for utility, you're going to be, in a conventional terms, you're going to be jack of all trades, master of none. So in those areas where whatever that mission set is requires mastery, then you're going to need specialization. I mean, there's just no two way around it. I mean, you can try and optimize across a couple of mission sets, but that very verb itself means you're making concessions somewhere else. And aviation is very much a compromise kind of sport. Over.
Yeah, that's a good point, Kofi. Does anyone else on the panel want to take a crack at this?
Sure,
Yeah.
Chris Anson here. So, yeah, I think it's definitely important to know where these fit and where they are. With the multi-role, it is a trade-off, right? I think with the current technology, keeping them light as we get in these multi-function, it's going to increase weight, complexity, cost. So I think as we break into the space within DoD, I think it's going to be important to maybe have that scope down where it's not a multi-tool, and it's going to drive cost up, and we need to really produce results with these early on as we make this transition away from conventional aircraft and other means of distribution.
Very good point. Commander Haywood, did you have anything you want to add?
No, thanks.
Okay. Does anyone else on the panel want to take a hit at this question, or should Sterling?
I'd like to add to it. Even
Sure thing.
in the urban air taxi mode, you'll have different configurations. Like Rory said on the missions, we've got the short hop, kind of like the metro. We've got the little longer range, the 70 miles gets you into work for those commuters. It's going to be a different configuration. And then we've got the regional rural mission, which is going to need a different configuration to be. We want these things to be cost effective in the market, and so the design is going to have to reflect that, energy efficiency, manufacturability, and those things to be cost effective and to have a market.
No, great points, Nancy. Thank you. Colonel Diller?
Just briefly with that, in Agility Prime in particular, we've kind of tried to keep that aperture relatively open. We have, as you know, if you go to agilityprime.com and look at the air race page, we identify those 3 areas of interest as a starting point, with the first being a 3 to 5 passenger vehicle looking at something can, fly somewhere, 100 miles an hour for 100 miles, carrying, that set of passengers. We've also looked in the area of interest number 2, looking at a kind of a 1 to 2 passenger. One, we think there's, the potential out there for some use cases where you really just maybe need a human at a particular location. And so you can think of maybe a disaster response scenario or some type of a surveillance scenario where you need, quickly a first responder to get there until a bigger team gets there. So some of those use cases. And then the third area of interest that we've looked at is this idea of a little larger cargo. So we've targeted specifically because our other services have done a great job looking at the group 1 through 3 UAS, specifically looking at things that are unmanned, weighing greater than 1,320 pounds for the max gross takeoff weight. And so I'd be interested among those 3 form factors from a utility perspective. We've done it largely because of different attributes we've seen in the space out there. Some of the AY3, right, the unmanned cargo, some interesting things that they're doing in terms of range extension. Some companies suggesting that they'll be able to fly, 1,000 miles with 1,000 pounds with a vertical takeoff and landing of vehicles that they have built right now. We'll see how those flight tests pan out over the next year, but very interesting looking at that type of a hybrid use. Others that are doing some very deliberate modularity with robotics to be able to attach and detach different payloads. On the 1 to 2 passenger versions, just the amount of data that's been collected and able to be collected by the approach of being able to fly under ultralight rules. So we've done it a bit as a mix of kind of a tech development portfolio, but interested from some of the folks that are on here, maybe going back to Bill in the Coast Guard, maybe back over to Chris or to Brain on the Marine Corps side. Among those, what do you see a bit as the trade-off between those, and in terms of near-term use, which among those do you see as having maybe the most value in the near term, assuming the flight tests all pan out to the specifications that are being suggested? Chris, maybe over to you first.
Sure, I'll take a stab at that. So yeah, out of the area of interest, off the top of my head, I would say the cargo piece, the area of interest 3. Risk is a little bit lower when we're moving, supplies around a battle space. So maybe that would be an entry point for the Marine Corps, and then maybe looking at the area of interest 2 with the in the CASEVAC instance. So definitely to gain confidence throughout the forces. This is a change. Pretty big revolutionary change the way that we look at things currently with manned aviation. So yeah, I'd say area of interest 3 in the near term for the Marine Corps.
Tom, do you want to follow up on that at all?
Yeah, I was just I'm really, this is sort of just my opinion on this topical area. It does more or less coincide with where we're going or what we're trying to do as a Marine Corps. But it seems to me, based on the majority of the technologies that are emerging, most of the air vehicles that are emerging, and then also looking at sort of the middle spot on a number of our requirements, that some kind of roughly 4-seat thing that can also do cargo. And I really think that the best analogy to this is the minivan, right? Mom's minivan that is not a truck, but man, you put the seats down and there is all kinds of cargo space. You put the seats up and you can haul the whole soccer team. That's not something we currently have, right? We got V-22s and we're optimized for speed and performance and carrying people, and we got 53Es that can carry tons and tons of equipment. But just having this sort of little utility thing that's easy to get into and get out of, it's got some unique features. It's got lots of extra communication devices built in that are automating this logistics process and making mom's job easier. That to me seems like the sweet spot in this new technology area. So that's just kind of my opinion on it. But I think that 1,000 to 1,500 pound payload, whether it's people or whether it's supplies or whether it's any number of things, seems like a pretty good place to be. That's all I got.
Super, thanks. Bill, other thoughts from the Coast Guard?
Pretty much the same thing, especially initially. I think doing what we call trash runs or log runs, or instead of using a C-130 to deliver a generator for an H-60 or something like that, if you had something like this that was a lot cheaper and easier to maintain, that you could send up and down, in our case, up and down the coast, or to an air facility, which is sort of like a forward operating base for us, that would be fantastic. That would be the kind of thing we could use it for. Again, I could always say, we struggle with that, and I'm sure the other services do, we really like this idea of a one-size-fits-all aircraft, and it's really hard, I think, to make it fit everything you want it to. You want a bomber and a fighter, you want a passenger vehicle and a search and rescue vehicle, you want something that can get on scene really fast, but then also have good hover capabilities. In my case, we're always talking about that. So you may not ever get to where you have one aircraft that can do everything, but for a lot of what we do, that what Colonel Heffern just described, that makes a lot of sense for us. Yeah.
Super, thanks. Yeah, one of the things, the discussion about, I think it's Rory talking about the elephant. We do still that we've had questions of, hey, you're going to try to replace the V-22 with this, and the answer is, you can't, right? There's times that you have the elephant because you need to go throw 3 or 4 people on there. The ants aren't necessarily going to be able to do that. So, but there are, I think the Marine Corps has highlighted this most, there's a lot of things the ants can carry. And if you can do that at a lower cost to save the elephant, when you really need the elephant, I think that portfolio mix is necessary. I think right now what we find a bit is we don't have that many things on the lower end of that portfolio. And if there's a way of getting something to kind of augment that portfolio, it creates just more efficiency, more value for that full portfolio. Rory, I see you coming off the mic there. I'll let you answer that, and we'll go back to Sterling for some of the other questions.
Yeah, just to expand, Colonel Diller, on that a little bit. a way to look at this from a logistics perspective may be, that last amount of distance, whether that's a couple of 100 yards or whether that's a couple of miles. Like currently, from a maritime perspective, the Navy may like to bring significant volume of supplies to their ships, and then they have a different distribution problem getting it from their ships distributed out to the fleet that is currently at sea. So while I can land a large aircraft on an aircraft carrier, I can't land a large aircraft on a smaller ship. So this is one of those kind of node concepts to transportation and or logistics, where you use the elephant for part of the journey and the ants for the rest of the journey. And there are challenges, as I'm sure Lieutenant Commander Haywood would attest to, for being at sea. And one of the things that the militaries never get to choose is generally the environment under which they operate, and having to do resupply missions in those situations. And that's just a single use case. There are many, many more. Over.
Great.
Question.
Sterling, yeah, if you could come up with the next question from the Q&A.
Trying to bring a few questions together. Michael asked how we envision putting humans in orbs will change our thinking, and then some of the other questions were around remote piloting versus autonomy and how the difference is there, and what aspects of autonomy really are key for the Air Force.
Well, we certainly don't need to keep that in the Air Force house, but does anyone have thoughts on this autonomy piece and semi-autonomous and piloting?
Sure, I'll take crack. Autonomy is huge, is very important. Are we going to get to a fully automated vehicle where we're putting humans in it and flying around? Probably not. And again, I kind of go back to the cargo piece with that as we really explore these autonomous systems to build confidence, across DoD, across the civilian population, across the world is really important. And I don't think it's going to be a jump in and start flying humans around right away. So, but as I mentioned before, operator training, the more that we can have, this artificial intelligence, these smart systems, these automated systems, taking the place of training. Maybe not, we've been using the word man on the loop, not necessarily in the loop. When we talk about autonomy, that may be, a crawl, walk, run approach as we move forward with autonomy. Like I said, cargo maybe up front, where human life isn't, in that aircraft. And then I know we'll get there. It's just a matter of time.
Great, thanks, Chris. Does anyone else want to take a hack at this?
Hey, this is Dana from OSEA. I know I'm not officially on the panel, but somebody left me here with the ability to talk, so I will. There was a McKinsey study that came out recently that was talking about how requiring a pilot in the system really hurts the economics for the commercial use cases, right? You're taking up a seat for one thing. You've got to have all the controls for another, so it complicates design. But most importantly, they were worried about the supply of pilots, right? We don't know what the simplified vehicle operations are going to look like. They probably won't be as difficult to fly as a helicopter, for example. But supplying enough pilots is going to be tough. And they argue that it's going to be difficult to recruit people to become pilots because the training is long and expensive. And all the firms eventually want to be autonomous. So you're asking people to sign up for jobs that might only have a 5 or 10 year lifespan. And so people won't want to make that investment. So the push for autonomy isn't going to go away on the commercial side either. They're going to push that very hard. Over.
No, that's a great point, Dana. And does anyone else have, oh, Nancy, do you want to respond to this as well?
Yeah, when I was talking about the risk of having any humans on board or not, but I think the one aspect is yes, the profile will be different, but we also have to consider that these will likely be operating over humans or in the vicinity of humans. So even though you're flying into a ship without anybody on board, you do have the LSC, the landing signal and on the ship who's on the flight deck who could be injured if the aircraft doesn't have the appropriate levels of safety. And as we do like to cite the Pan Am accident in New York, where one of the people that was killed was not on the aircraft. They were killed by debris. So yes, there is a difference, but we need to look at the whole picture when we look at risk and safety for these vehicles, whether people are on board or not on board.
Yeah, that's a great point, Nancy.
There's a couple of things, and I've spent some time thinking about that problem. So to Dana's point, that's true, because the company side of it's going to need to see the profitability aspect, and they see, and I'll just talk bluntly on it, they see us as, 200 pounds of dead weight occupying the space of a passenger. And I'll come back again to Nancy's comments when you offboard things from the aircraft. So what is it that the pilot does on the aircraft? And yes, there is a little bit of stick wiggling in terms of manipulating the controls. But the thing that the pilot also does in the aircraft is acts as an interface with the outside world. So there's no autonomous system. There's no system out there that is operating in complete autonomy, except for maybe the universe, right? In other words, even a pilot on an airliner right now is getting controls and inputs from ground-based people that are looking at a different picture than that person is, and they're making adjustments to their flight path and going on. So if I'm going to offboard that capability, which is the capability to communicate, the capability to adjust, the capability to change, I'm going to have to put it somewhere else. Particularly now, if you want to carry people on board, we talked about the pedigree of the aircraft, and if you think about some of the systems that have the best pedigree out there, again, I'll come back to the NASA stuff. I think about a satellite. You're talking about one of the most mature and technologically kind of wrung out systems that's put into space, because once it's up there, it's up there. So if you were to have immaturity and risk with it, all of that would disappear. And then when you take a look at all of the stuff that was offboarded because it's extreme in terms of the weight, take a look at what it takes NASA to run, a mission or a satellite in space, or even just the launching of it. All of those people are now the pilot, right? Contributing to that mission. So along those lines, we'll run into similar situations when you start taking capability out of an aircraft. And I do believe the pilot is just a capability in an aircraft. It's just another computing thing, and moving it somewhere else. So if we think about the functions of the operators and we want to move those somewhere else, that might be a way. And that is a trade. Like if I get rid of the 200 pounds of self-loading baggage, what can I use that 200 pounds for? Over.
Great, thanks, Joel Peely. From my clock, we have a little over 5 minutes left, so I wanted to take this time to hand it back over to Colonel Diller for closing comments.
Quickly, and I wanted to say that for all the panelists, if you're able to or willing to, if you could post your email or some form of contact in the chat. A lot of people wanted to reach out with further questions. Thank you, guys.
Thank you, Sterling. But yeah, back over to you, Colonel Diller, to wrap things up and close us out.
Sure, Super. I'm going to try to run through a couple of the questions that we didn't get to, and I'll try to do a little bit of rapid fire. I think we talked a bit the aspects of autonomy. I think probably the most important thing is continuing to just improve safety of flight. I think Nancy spoke to this really well. Just the things, being able to make vertical flight safer in the near term is certainly an area that there's some great efforts that have been done on existing vertical VTOL aircraft right now, and I think there's progress that's been made there. But I think that piece of the autonomy certainly would be one of the first steps as we continue to progress along. And it's interesting to see the roadmaps that many of the companies have of collecting data, eventually how that data starts to be fed into a level of trust in these vehicles. So I think that's important. Another question on payload size. What is the most interesting? I think you heard from this crowd here, kind of that idea, some of the ideas that are out there, certainly payload of all sizes, but the, potentially this concept of modularity, where you have a minivan of sorts to be able to move personnel or equipment, that the idea of a modularity where maybe you actually have something that's attached and detached, that some of the companies are looking at right now. but you see, I think our areas of interest will allow us to explore that a little bit further. There's cases where, just maybe 1 or 2 people is sufficient. But certainly that is a key item that we'll be looking to address as we progress on. There's a question about funding through Agility Prime. So you can all see right publicly out there for FY19, there was a $10 million that was out there. For FY20, another $25 million. And so, and then a variety of different SBIRs. We are going, as I mentioned last week, the SBIR program, the parts of that associated with a lot of the phase 1 and phase 2 efforts on the commercialization side have moved under a program called Air Force Ventures. Internal to Air Force Ventures is one of 3 parts of a restructured AFWERX organization. So I took over as the director of AFWERX. I continue to lead the Agility Prime effort, working with counterparts who have done the previous AFWERX outreach. They continue to do that, and we continue under Air Force Ventures to restructure the SBIR. So we'll look to continue to find opportunities for additional funding, both for small businesses and large businesses alike, as we focus in the near term, though, on testing. So of our research, development, testing, and evaluation funding, the majority of that we are looking at, given the strategy that's been dictated for Agility Prime, is for that test and evaluation piece, and we'll continue to do that. And then as we look forward, a couple of other items to highlight. There were some discussions there, what does it look like in the future? Are we going to, is there going to be weaponization of these vehicles in any form or fashion? Right now, as has been discussed, we have other tools in the toolkit that do that work right now that we're pretty satisfied with. It's really this lower end, this ability to quickly move people and equipment around, where we see this, and we see that based on the maturity, those are where we're going to get the most bang for the buck out of that. And so that's where you look at, it is this humanitarian response. It's this personnel recovery. A lot of the Coast Guard missions, being able to do search and rescue, where we see getting the most value out of these vehicles in the near term. I want to thank the panelists. Really a fantastic job. Not many times you're going to be able to find kind of that breadth across the services, looking at new technologies, doing it in a collaborative way. We certainly welcome all of you to come back here. We welcome the collaboration. There's an analytics effort that we've kicked off that we plan to bring to our Wednesday webinar here in the not so distant future, showing how we're looking at kind of this multi-user case to identify where we might be able to do collaborative research. And through this collaboration, as well as through this learning campaign, we feel like we will be able to accelerate funding and accelerate the ability to take these vehicles to market. Several folks that asked to get in contact, please don't forget to find both this webinar and our previous webinars. If you go to the Agility Prime webpage and you look at the webinar page, you'll see those previous weeks that are uploaded there. We continue to populate that into the future. Also, I'll make another shout for next week, looking to have a discussion about autonomy, as was addressed here. We have a lot of programs in the Department of Defense that have been working on autonomy. We feel like there is an opportunity here based on our approach to risk management to accelerate a lot of the autonomy work and hopefully transfer a lot of that autonomy over into the commercial sector, maybe at rates that are faster had DoD not been involved. So we will be talking about autonomy, and we will have one of the biggest advocates for autonomy here to speak with us. So Dr. Will Roper, expecting him to be here next week for a couple of special announcements as we follow up with that autonomy discussion. Questions about some of the future funding that we have. Continue to stay tuned as we explore the opportunities where we can do the collaboration between universities and industry through an STTR. Potential opportunities to do that even outside of the standard cycles there, because we just think it's so important for that workforce development, for developing the relationships between industry, between academia, and between government, so that into the future, we will be able to get to the fantastic use cases that were discussed here, and that we will be able to fly orbs into this new era of aerospace. Thank you for joining us this afternoon. Thanks so much to our panelists, and look forward to seeing everyone next week. Goodbye.